December 15th, 2025. The Vera Rubin Observatory in Chile detected something impossible. A star in Orion was flickering like a broken streetlight. Within hours, astronomers worldwide confirmed their worst fears. A rogue black hole, 10 times the mass of our sun, was heading straight for us. ETA, 18 months. This isn't science fiction anymore. Right now, as you're watching this, there may be 1 billion stellar mass black holes wandering through our galaxy. Invisible, silent, pure gravitational destruction, moving at hundreds of kilometers per second. We found our first confirmed rogue black hole in 2022. They're out there. So what happens if one crashes our cosmic neighborhood tomorrow? The answer depends on 3 things: mass, speed, and trajectory. Today, we're exploring every scenario physicists have calculated. From "we might survive this" to absolute nightmare fuel. And trust me, some of these will completely rewrite your understanding of cosmic threats. Here's something that'll blow your mind. A typical stellar mass black hole has 10 times our sun's mass. Its actual size? A sphere just 60 kilometers across, small enough to fit inside the Greater London area. An object that fits inside a major city with the gravitational pull of 10 suns. That's not just dense, that's reality-breaking dense. And here's what keeps astrophysicists awake at night. We wouldn't see it coming. Unlike asteroids that reflect sunlight, a lone black hole is perfectly black. It eats everything, reflects nothing. The first sign wouldn't be a growing dot of light. It would be something way more subtle and terrifying. Picture this: you're studying distant stars, when suddenly, one that's been stable for decades starts acting weird, brightens, dims, back to normal over a few weeks. That's gravitational microlensing, something massive bending light as it passes between us and that star. But here's what terrified the scientists who found it. In 2022, astronomers Casey Lamb and Jessica Liu used exactly this method to confirm the first isolated black hole. They called it MOA-191. Took them over a decade to prove what they'd found, because finding a rogue black hole is like finding an invisible needle in a cosmic haystack. But our detection game is about to explode. The Vera Rubin Observatory comes online in 2025 with a 3.2 gigapixel camera. It'll photograph the entire southern sky every few nights. If a rogue black hole started approaching tomorrow, Rubin would spot the gravitational lensing months or years before it reached us. That's our early warning system. But warning for what exactly? Let's follow the timeline of an actual encounter. Our hypothetical black hole, let's call it Nemesis, is 2 light years away, moving toward us at 150 kilometers per second. That's 10 times faster than Voyager. At this distance, Nemesis is plowing through the Oort cloud, a spherical shell of trillions of comets extending nearly 2 light years from the sun. And this is where the chaos begins. Nemesis's gravity starts flinging comets everywhere. Some get ejected completely. Others get thrown into crazy elliptical orbits that send them careening toward the inner solar system. Here's the terrifying part. This comet bombardment wouldn't happen immediately. Could take decades or centuries for these disturbed comets to complete their new orbits and reach us. So even if Nemesis passed through without hitting anything directly, we'd be dealing with increased comet impacts for thousands of years afterward. Think of it as cosmic billiards. Nemesis is the cue ball, and every comet it disturbs becomes a potential projectile aimed at Earth. As Nemesis gets closer, there are three main scenarios physicists have calculated in detail. Scenario Alpha, the near miss. This might sound like the good news scenario, but it's actually one of the most devastating. Nemesis doesn't hit Earth directly, doesn't even come close. Instead, it passes within a few astronomical units of our planet. But gravity doesn't require contact. As Nemesis swings past, its gravitational field acts like a cosmic slingshot. Earth gets grabbed, accelerated, and flung out of its stable orbit around the sun. We become a rogue planet, ejected into the freezing darkness of interstellar space. The timeline is brutal. Within weeks, Earth's temperature drops below the freezing point of carbon dioxide. The atmosphere starts freezing and falling as snow. Within months, the surface becomes colder than Antarctica's worst winter. But here's something wild most people don't realize. Earth wouldn't necessarily become completely lifeless. Deep in the ocean, around hydrothermal vents, life exists that doesn't need sunlight. These ecosystems run on geothermal energy from Earth's core. And that core would keep producing heat for millions of years, even in interstellar space. So while the surface becomes a frozen wasteland, life could theoretically survive in deep ocean trenches. It's not much consolation, but it shows just how tenacious life can be. Scenario Beta, direct consumption. Hollywood loves this one, but the reality is way more complex and terrifying than any movie. Let's say Nemesis is on a collision course with Earth. What actually happens? First, forget everything about black holes sucking things in. That's not how gravity works. Black holes don't suck any more than the sun sucks planets. The danger comes from something called tidal forces. Here's the key concept. Gravity gets stronger the closer you get. So if you're falling toward a black hole, the part of your body closest to it experiences much stronger gravity than the part farthest away. This creates stretching. You get pulled apart lengthwise while being compressed from the sides. Physicists call this spaghettification, and it's exactly as unpleasant as it sounds. For Earth approaching a stellar mass black hole, spaghettification would begin when we're still thousands of kilometers from the event horizon. The planet gets literally torn apart by the gravitational gradient. But here's where it gets visually spectacular in the most horrifying way possible. Earth's debris doesn't just fall straight in. It forms an accretion disk, a swirling, superheated spiral of matter. Friction heats this material to millions of degrees, making it glow brilliantly in X-rays and visible light. If you were observing from a safe distance, you'd see Earth transformed into a glowing disk brighter than the sun. That accretion disk would sterilize any remaining life in the solar system with intense radiation long before the physical destruction finished. But wait, there's an even more mind-bending scenario. Scenario Gamma, solar capture. What if Nemesis doesn't hit the sun directly, but captures it into a binary orbit? This creates something unprecedented in our solar system's history. A double star system with planets. Gravitational chaos would be immediate and catastrophic. Planetary orbits stable for billions of years would become wildly elliptical or completely unstable. Some planets get ejected entirely. Others might find bizarre new orbits around both the sun and the black hole. Here's the fascinating part. Earth might actually survive this, at least initially. If we ended up in a stable orbit around both objects, we'd have two suns in our sky. The familiar yellow sun, and a brilliant accretion disk formed as the black hole slowly feeds on solar wind. The night sky would be transformed beyond recognition. Depending on our new orbital period, we might have days lasting months, followed by months of darkness. Climate would become completely chaotic, but life might adapt. This scenario could create a new, stable system lasting millions of years. Alien and hostile, but stable. Now let me tell you about the scenario that sounds like science fiction, but is actually most plausible. There's a special type called a primordial black hole. These formed in the early universe, not from collapsing stars. They could have any mass, from microscopic to stellar. Imagine a primordial black hole with the mass of a large mountain, about 10 trillion kilograms. Sounds massive? Its physical size would be smaller than a proton. If this thing passed through Earth, most of us wouldn't even notice it happening. It would zip through the planet in seconds, creating a narrow tunnel of superheated, vaporized rock. The entry might cause some seismic activity, like a moderate earthquake. But the exit would be more dramatic, as suddenly vaporized rock explodes outward. The scary part? We'd have almost no way to detect this before it hit us. Too small to cause significant gravitational lensing, moving too fast to perturb planetary orbits noticeably. You could have one pass through your backyard right now. The only sign would be a mysterious small earthquake, and maybe some unusual rock formations. So here's the question everyone wants answered. How worried should we actually be? Good news, space is really, really big. The probability of a rogue black hole entering our solar system in the next million years is astronomically small. We're talking odds that make winning the lottery look guaranteed. But, and this is crucial, the probability isn't zero. We know rogue black holes exist. We know they're moving through our galaxy. And on cosmic timescales, close encounters between stellar objects do happen. The real value in studying these scenarios isn't creating panic. It's understanding our cosmic environment and developing technology to detect potential threats. Right now, we have three major systems mapping our cosmic neighborhood. Vera Rubin will detect gravitational lensing events. LIGO gravitational wave detectors prove black holes are common and active in our galaxy. And the European Space Agency's Gaia mission is creating a hyper-accurate 3D map of over 1 billion stars, which could reveal gravitational influence of nearby dark objects. Here's what really keeps me up at night, though. It's not the black holes we might detect. It's the ones we can't. Current estimates suggest up to 1 billion stellar mass black holes in our galaxy. We've directly detected maybe a few dozen. That means 99.99% of black holes in our cosmic neighborhood are completely unknown to us. They're out there right now, invisible and silent, following orbital paths around the galactic center. Most will never come near us, but statistically, some will. The universe isn't a safe place. It's a dynamic, chaotic environment where massive objects move at incredible speeds and occasionally intersect catastrophically. But here's the beautiful part. We're not helpless observers anymore. For the first time in human history, we have technology to see these threats coming. We can map the invisible, calculate trajectories decades or centuries in advance. Every scenario we've discussed today is based on real physics, calculated by real scientists. The gravitational effects, orbital mechanics, tidal forces, all modeled and simulated using our best understanding of how the universe works. And that's what makes it both terrifying and amazing. We're living in an era where we can not only imagine these cosmic disasters, but actually predict how they'd unfold. Next time you look up at the night sky, remember what you're really seeing. Those aren't just pretty lights scattered across black canvas. You're looking at three-dimensional space, filled with massive objects in constant motion. Stars, planets, black holes, neutron stars, all following fundamental physics in an intricate cosmic dance going on for billions of years. And we're finally learning the choreography. So what do you think? Which scenario seems most likely? And more importantly, knowing what we know now, how should humanity prepare for these cosmic threats? Let me know in the comments. And if you want more scenarios about what happens when the universe gets dangerous, hit subscribe. Trust me, we've only scratched the surface of cosmic catastrophes. Next week, we're exploring what happens if two black holes collided near Earth. That scenario makes everything we discussed today look like a gentle cosmic breeze. Until then, keep looking up, but maybe with a little more respect for just how wild and dangerous our cosmic neighborhood really is. The universe is vast, beautiful, and absolutely terrifying. We're just beginning to understand our place in it.